Welcome to another intermediate algebra video. In this video, we'll look at another method of solving quadratic equations, specifically with the quadratic formula. So here are our objectives for this section. Specifically, solve quadratic equations using the quadratic formula. Remember, there are lots of different methods we can use to solve them, but quadratic formula is the one we're going to focus on in this video. And then also determine the number and type of solutions to a quadratic equation using one piece of it called the discriminant. So let's see what that formula looks like. So here are our notes on the quadratic formula. In order for us to use quadratic formula, we need it to be in this format: ax squared plus bx plus c equals 0. The most important piece here is that it's equal to 0. If it's equal to 0, you can reorder your terms and always identify a, b, and c without much of a problem. All right, so if we are, we get our problem to be in this format, then what is the quadratic formula? So a, b, and c are just numbers that will exist in your equation. And so here is the quadratic formula. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. Some of you may have remembered this formula, maybe not. I can tell you this is a formula that you're going to need to know. So when it comes to a test, or even as you move on through college algebra, you'll need to have this formula memorized. A, b, and c are just numbers, so while it is a complex looking formula, there are lots of YouTube videos out there with jingles on how to remember them. A, b, and c are just numbers, so it looks crazy, but all you're going to do is plug in those numbers and compute. At the end of this video, I'll show you the proof on how we got from here, from the initial problem, the initial equation equal to 0, to the quadratic formula itself. So another important note about this is that the fraction bar goes all the way. I often see students only draw the fraction bar underneath the radical and only put the 2a under the radical. It's the whole thing. The 2a is underneath everything. You could separate it to be two fractions, and then that 2a would apply to both the individual negative b and the individual radical, but it does need to be under both. Okay, and then the second objective notes are about the discriminant. The discriminant is a specific piece of the quadratic formula. You can see it is the piece under the radical. And the goal is the same here in these problems. Ultimately, we're looking to solve, so we'll find the potentially two solutions that exist from here. But the discriminant, just the discriminant, can tell you how many and what type of solutions there are. So if you can imagine these being all numbers, if underneath this radical we simplify and we get a positive number, if this is positive, then we have number plus or minus square root of positive number. Well, you can have the square root of a positive number. That's fine. That means you have the plus version and the minus version. So essentially, there are two real solutions. If you get negative underneath that radical, so picture there's a number, you have plus or minus a negative number, whatever that number might be, all over a number. If you have a negative underneath that radical, that negative comes out as an I, and you still have a plus and a minus. So there are two real solutions. And finally, if underneath that radical you get a 0, negative 6 plus or minus, blah, 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 everything in there boils down to 0, well, the square root of 0 goes away, and you have negative 6 plus or minus 0, negative 6 plus 0, negative 6 minus 0. It's the same thing, so you essentially get one real solution. So first we'll look at actually solving, and then we'll look at the discriminant telling us how many and what kind of solutions we could have. So here's our first problem, solve using the quadratic formula. Let's write that formula one more time. x equals, x being what we're looking for, negative b plus or minus the square root of b squared minus 4ac all over 2a. So, do we have it in the format that we need? Is everything on one side and it's equal to 0? In this case, the answer is yes. So we can identify a, b, and c. A is the coefficient on the x squared term, which is 3. B, the coefficient on the x term, which is 16. C, the coefficient, or the constant term that's left over, 5. So these are the numbers that we are plugging into this formula. So we have x equals negative b, 16, plus or minus the square root of b squared, 16 squared, minus 4 times a, which is 3, times c, which is 5, all over 2 times a, which is 3. Once the numbers are plugged in, it's a matter of running the numbers and simplifying. Now, you can't type everything into your calculator all at once because it'll give you a decimal approximation, which is not what we want. We want exact answers. But you can do certain pieces at a time in the calculator. So let's start with the piece just underneath the radical, which is the discriminant. Do 16 squared minus 4 times 3 times 5. Looks like we get 196. If you need another line to get there, that's okay. In the denominator, 2 times 3 is 6. So then we continue simplifying this. The square root of 196. I believe it is a perfect square. Yep, looks like it is. If you type it in the calculator in the square root, with the square root button, you'll find that it's 14. Or you could take that 196 and break it down. 2 and 98. 98 breaks down to 2 and 49. 49 to 7 and 7. So you have a pair of 2s and a pair of 7s, which essentially give you 14. So we have negative 16 plus or minus 14 all over 6. And we actually can keep going with this one. Because there are numbers, it's not a radical. Oftentimes we're left with a radical stuck with the 14. We can separate them and get two clearer solutions. So let's separate. Negative 16 plus 14 over 6 and negative 16 minus 14 over 6. Simplify each one. Negative 16 plus 14, negative 2, which simplifies to negative 1/3. And the other solution, negative 16 minus 14, negative 30. Negative 30 divided by 6 is 5. So our two solutions are negative 1/3 and 5. And this is using quadratic formula. So yes, we do have other options. You could complete the square on this one. It looks like you could factor for this one. This is a method that we've had previously, but not one that we're focused on in this section. You couldn't explicitly use the square root property, but through completing the square you could if you wanted to. But quadratic formula will work every single time. And if you know the formula, then it's one of the easier ones. So long term, this is probably a method you'll use more often. But again, we find the two solutions that work here. You could verify them if you want to, but you don't have to. All right, let's do another one. Next one, solve using the quadratic formula. We have 3x squared minus 8x equals 2. In order for us to use the quadratic formula, we need it to be equal to 0. So we subtract 2 from each side. Then identify a, b, and c to plug into the formula. Our a is 3, our b is negative 8, and our c is negative 2. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then let's plug them in. So negative b, our b is negative 8 minus negative 8 plus or minus b squared, so negative 8, quantity squared, minus 4 times a, which is 3, times c, negative 2, all over 2 times a, which is 3. Continue simplifying from here. Minus negative ultimately gives us positive. Underneath, we have 64. 4 times 3 times negative 2, so we have, or even negative 4 times 3 times negative 2 gives us plus 24 all over 6. 64 plus 24 gives us 88. Let's see if there's any pairs in 88 that we can simplify. 8 times 11, 4 times 2, 2 times 2. Looks like a 2 comes out, and we're left with a 22. Oops. The x doesn't need the fraction bar, just the 8 and the radical. And then it's very tempting to say that this is good, but if you notice 8, 2, and 6, they all have a 2 in common, so we really should take that 2 out. Divide everything by 2. It's sort of like taking a 2 out of the top and bottom. You can factor if you want to. I really think it throws people off to see everything there. I'll write that line, but ultimately this is what it would simplify to. If you wanted to see a previous line, you could say, sure, we factored a 2 out of the numerator, and 6 is 2 times 3, so cancel those out, and that's how we get 4, plus or minus the square root of 22 over 3. Your solutions can look a little crazy, and that's because thus far, if we've solved quadratic formulas, before this unit, we were only able to factor, and so we were only given problems that factored, which meant their solutions were kind of nice. But the truth is, the solutions aren't always nice, so this is how you handle it if you can't factor and the solutions are kind of crazy. All right. Go ahead and pause the video, run through this one on your own, and then we will go through it together in a moment. All right, so the first thing we need for this problem is to be equal to 0. Now you have two options, so you may have gone through this a couple different ways. You could subtract x, bring it over to the right, or you could add 3x squared and add 3 to both sides, getting everything on the left. It's your call. You'll end up with the same solution either way. I'll show you how your solution would differ. But my choice would be to add the 3x squared and the 3 to both sides because I like positive numbers, and if I move everything to the left, they'll all be positive. It's just a matter of preference. There's no better way to do it. Okay, so it's equal to 0, which means I can go ahead and use quadratic formula now. My a is 3, my b is 1, and my c is 3. They have to be in this order, x squared, x number. And if they're not in that order, you just have to pull a, b, and c from the right places. A, coefficient on x squared, b, coefficient on x, c, the constant. All right, so plug it in. The formula again, negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug them in. Negative, our b is 1, plus or minus square root of b squared, 1 squared, minus 4 times 3 times 3, all over 2 times 3. Okay, good. All right, so let's start to clean those numbers up. Negative 1 plus or minus 1 squared is 1 minus 4 times 3 times 3. 36 all over 6, 2 times 3. Negative 1 plus or minus the square root of negative 35 over 6. And then simplify that radical if you can. The only thing we can do with it is take out an I, which is okay. I solutions are part of the picture. And we get negative 1 plus or minus I square root of 35 over 6. All right. Now let's look at the last objective here, which is identifying how many solutions and what kind of solutions a problem will have. So maybe you don't necessarily care what the numbers are. You just want to know, if I solved this, would I get real solutions? Would I get imaginary solutions, meaning they involved I? Would I get 2? Would I get 1? What would happen? So this is how you can answer that. So remember, this comes from the discriminant, which is a piece of the quadratic formula, the piece under the radical. If you have a positive number, you have 2 real solutions. A negative number, 2 imaginary solutions. Imaginary or complex, you can say it either way. And a 0 means 1 real solution. So this is going off of the quadratic formula, so it needs to be in the format that the quadratic formula needs. So for our first one, all we care about are how many and what kind of solutions. X squared plus 2x plus 1. It's in the right format. Our A is 1, our B is 2, and C is 1. So we plug them into just b squared minus 4ac. So we have 2 squared minus 4 times 1 times 1. We get 0. And 0 implies 1 real solution. That's the ultimate answer here. Let's fix that. 1 real solution. Now, if you don't like just looking at that, you're more than welcome to go through the entire process of using the quadratic formula and come up with a solution. You just ultimately have to answer the question, how many solutions did you get and what kind are they? Meaning, are they real or are they imaginary or complex? So a 0 means 1 real solution. You can go through the process, you can go through and find out. You will only get 1 solution. Okay, for the second one, we have 3x squared plus 2 equals 0. Again, we only want how many solutions and what kind. So we identify A, B, and C. A is the coefficient of the x squared. B is the coefficient on the x term. We don't have one, so it's a 0. And C is the number by itself, 2. So plug them into b squared minus 4ac, the part that would be under the radical. Our b is 0 squared minus 4 times 3 times 2. We get 0 minus 24. We get negative 24. This number does not tell you what the solution is, it tells you what kind. In this case, we got a negative number, which implies 2 imaginary or complex, it's the same thing, solutions. This is the answer we're looking for here. The question is how many solutions and what kind, not solve. If it said solve, then solve it. But just be careful. I have a lot of students often just solve it and then not answer the actual question. Sometimes this is the only piece you have to do, is find out how many solutions. Sometimes you do have to solve. Okay, so go ahead and practice this last objective, and then we'll go through it together after you pause the video, and we'll see how it went. Okay, so in order to use the discriminant, it needs to be in the quadratic formula format, which is equal to 0. So we subtract 1 from each side. Then identify A, B, and C, and plug them in. B squared minus 4ac. We have negative 3 quantity squared minus 4 times 1 times negative 1. We get 9 plus 4, which is 13, which implies it's a positive number, so it means 2 real solutions. The ultimate answer to the question, how many solutions? 2. And what kind? They're real. 2 real solutions. Answers all the questions. So in this video, we looked at the quadratic formula in a few different ways. We solved problems using the quadratic formula, and then we used a piece of it, the discriminant, to tell how many and what kind of solutions a problem would have. I'll see you soon for another video.